So today we're going to apply SOHCAHTOA. We're going to apply what we have learned about trig ratios to actual real life situations, okay? Sometimes you won't be able to use Pythagorean theorem for everything, and that's why we learn SOHCAHTOA. That's why we learn trig ratios. So first let's review a little bit. Sine is opposite over hypotenuse. Remember, SOHCAHTOA. Cosine would be adjacent over hypotenuse. SOHCAHTOA. And then tangent would be opposite over adjacent. Okay, SOHCAHTOA. So let's talk about the angle of elevation. So in our picture here, the angle of elevation is always out and up. Okay, out and up. Jot that down. So you'll notice that here, X marks our spot, right? Out and up. So let's look at angle of depression though. This one's different. This one's going to be out and down. So out and down. But I want to show you something special here. I'm going to use red because you don't have to write it down. These two lines are parallel to each other. And what you might have forgotten is that if I do my transversal right here, this angle right here, our angle of depression, right? That was our angle of depression out and down, is equal to this right here because they are alternate interior angles. So this guy right here is your angle of depression, but what's this? That's your angle of elevation. So anytime they give you an angle of depression, you can go ahead and make your angle of elevation the exact same thing, which is what I have written down here. So your angle of elevation is the same as your angle of depression. So just remember that as we go through some of these problems here. So let's go ahead and start with our first example. You will have to draw pictures. You will have to pause and actually think about what's going on here. It says a person in a 21-foot tall lighthouse. Okay, so here we have our lighthouse and we have a person at the top of it. All right, I'm just going to do a happy face. Now they said this is 21 feet tall. Okay, they spot a boat in the distance. So here's our boat, okay, out in the distance. They're spotting it. So let's go boop, like that. The angle of depression to the boat is 32 degrees. Now be careful, because angle of depression would be out and down, and that would be 32 degrees, out and down. But remember what we said. The angle of depression, the angle of the elevation are the same because we have parallel lines which cause alternate interior angles. So if I turn this into a triangle right here, if this is 32 degrees there, this must be 32 degrees right there. Okay? And I'm going to use this triangle right here. And we're going to take care of this the exact same way. It says, how far is the ship from the lighthouse? Here's the lighthouse, here's the ship. So they want to know how far this way it is. Not from my face to the ship, but from the lighthouse to the ship. So we'll put an X there. So we have 32 degrees here, we have an X there, and we have a 21 here. And we're going to take care of these problems the exact same way we've been taking care of them before. We circle our reference angle, and we label what we know. So we know that our opposite is 21, so we label that. And we don't know the hypotenuse, so we don't label the hypotenuse. And then we have an X here for our adjacent. So we have to think about SOHCAHTOA. So with SOHCAHTOA, what deals with an opposite and an adjacent? What deals with an O and an A? And that's going to be tangent. So we're going to take the tangent of 32, and that's equal to our opposite, which is 21, divided by our adjacent, which is X. And we're going to solve that. Now, X is dividing in, right? So to do the inverse of that, to undo it, we're going to multiply both sides by an X. And then we can cancel these out. So now we have X times the tangent of 32 equals 21. But X isn't alone yet. Tangent of 32 is multiplying on our X. So we're going to divide both sides by a tangent of 32. So divide by tangent 32, divide by a tangent of 32. And we'll cancel this out. So now, this is a side, right? So if it's a side, we're going to go ahead and round to the tenths. We're going to do 21 divided by the tangent of 32 on our calculator, and make sure you're in degrees, which I am. And this 0 will not do anything to this 6. So we're going to say 33.6. And what are the units? 33.6 what? Feet. Okay, that's how far away the boat is from the base of the lighthouse. All right, so let's keep going. Let's check out number 2 here. A 40-foot tree casts a shadow 58 feet long. So if we have our tree here, okay, and you don't have to be a really good artist. As you can see, I'm not. It casts a shadow. Now this tree is 40 feet, and this shadow is 58. Find the measure of the angle of elevation of the sun. What's happening here is the sun is here, and it's causing the shadow to be created, right? The sun causes a shadow. So we're going to go like this, and it says find the measure of the angle of elevation. So that's out and up. So out and up would be right there. Now we're going to take care of this the exact same way that we've always done it. We're going to circle our reference angle, and we're going to label. So we do know our opposite's 40. We do not know our hypotenuse, so we don't write the word hypotenuse. And we do know that our adjacent is 58. And this problem is very similar to the last one because it deals with opposite and adjacent. And we know with SOHCAHTOA, that's going to be tangent. So we're going to have the tangent of x equals the opposite, which is 40, divided by the adjacent, which is 58. Now I can't type tangent x into my calculator, so that's my tip-off. My tip-off to know that I have to do inverse. So we hit the second and then we hit the tangent key and we type in 40 divided by 58. Now in my class, whenever we do angles, we round to the nearest degree. So looking at this 5 right here will round this 4 up to a 5. So this is going to be about 35 degrees. So x is about 35 degrees. That's our angle of elevation to the sun in this situation. Okay, remember if I'm going too fast, you can pause it, go back and rewatch it, do whatever you need to do to solve the problems. So let's talk about 3. I want you to do that one in class, okay? Or do that one for class, I should say. So go ahead and try number 3. You can try it now. You can try it at the end of the video when I'm done, whatever works for you. But go ahead and try number 3 and bring that one to class. And number 4 you can try also, but I will definitely do this one in class with all of you, okay? So you can try it if you want, but I will definitely do number 4 in class. You don't have to have it done for class. I want to talk about it with you. So the last one I'm going to do with you guys is number 5. So Jason's office is in a skyscraper 270 feet high. So we're just going to assume that Jason's at the top here, and this is 275 feet high. And he's looking out the window and he sees his buddy Reggie on the street below. So here's Reggie right here. So he's looking out the window and he sees Reggie. So there's your triangle, right? If Jason calculates the angle of depression is 71. So remember, angle of depression is out and down. But we know because of parallel lines and alternate interior angles that our angle of depression is the same as the angle of elevation. So we can say that this is 71 right here. How far is Reggie from the base of the building? So here's the base of the building and here's Reggie. So we want our x right there. And we're going to take care of this the same way. We circle our reference angle, which is 71, and then we start labeling what we have on our triangle. So we know our opposite's 275, and we don't happen to have a hypotenuse here, so we will not label it, but we do have an x for our adjacent. And again, what deals with opposite and adjacent? And by chance, this one happens to be tangent again. Now, they're not always tangent, just to let you know. It's just by chance in my video, they're all tangent, okay? So the tangent of 71 equals the opposite, which is 275, divided by the adjacent, which is x. Now, we want to get x alone, but first we have to take care of something. X is dividing into 275. So to undo that fraction, we're going to multiply both sides by an x. So now we have x times the tangent of 71, and that equals 275. If we want to get x alone, we have to do the inverse. So if tangent of 71 is multiplying, we're going to have to divide both sides by the tangent of 71, like that. So now we'll have 275 divided by the tangent of 71. And we're finding a side here. So I want to round to the tenths. Now, if I'm rounding to the tenths, that's one place out. So this 9 will definitely bump up this 6. So we'll have 94.7. And we have to ask ourselves, what are the units? So it's 94.7 feet. Okay? So that's about how far away Reggie is from the base of the building. So if you could have number 3 done for class, and then number 4 I will discuss in class. So bring that with, and I will see you then. Have a great night.